look at this. We have our graphed parabola perfectly every time, fast, easy. All you need is two numbers and you got it. Follow me every step of the way and you will succeed. I promise you that. Here it is. Hey everybody, I'm Nate Rakes and I used to teach Algebra 2 for years, and so I'm going to show you how to graph a quadratic equation perfectly every time with a little secret sauce that I have for all of you that need a little extra help. Here we go. This equation right here is in vertex form, and vertex form is beautiful because it is giving us the vertex. The vertex of a quadratic is the middle. So it's that bottom point, or if it's upside down, it's that top point. It is the middle of our graph. That is key because either side is symmetrical, which means it's the same. So we're going to use that to our advantage. Ready? Here we go. This is in vertex form, which means that this is showing us the vertex. The x plus 3 is giving us the x coordinate, and the minus 1 is giving us the y coordinate. For the x coordinate, because it's inside those parentheses, it is always the opposite. So our vertex is, the x is -3, because it's always the opposite of what you see in there, and the y is the -1. It is the same as this guy. Now we're going to use a table to help us get the rest of this equation, or the rest of these points down. But what does that vertex look like, right? Can we graph that? Well, I'm so glad you asked me, because yes, we can. It looks like this. -3, we start at the origin right here, and we go 1, 2, 3. That is our x value, and then -1. That is our y value, and then we can graph that point right there. Listen, don't judge me. Don't critique me. It's not to scale. That's what I used to tell my kids. It's not to scale. Here we go. So how do we use a table to help us, or how do we use this to help us? Well, I use a table, an XY table, and I use the coordinates just above and just below our vertex. So what's just above, or maybe just to the right? It's -2, -1, and just below, or just to the left, is -4 and -5. Now, Nate, how do we get these y values? I don't understand. Listen, follow me and I got you. And it's going to be symmetrical. So all we need is one side, and we're going to get the other side. Here it is. We're going to use the original equation, which I know you can't see it right now, but here's what it was. It was y, well, I want to use red, baby, red, red, red. It was y equals x plus 3 squared minus 1. Oh boy, I got some other stuff happening down there. That's cool. See you later. So all we got to do is plug in these x values, like this guy, like this guy right here, into this equation right here for x, and we'll get it. So if we plug it in, y equals -2 plus 3 squared minus 1. Well, let's solve it, right? Do the parentheses first. -2 plus 3 is +1. +1 now squared is still 1. -1 equals 0. Boom. We have our next point. So we can graph it, right? We go over to, from the origin, -2, 0. We don't have to go up and down any. Boom, there it is. And well, don't let me get ahead of myself. Here we go. Let's do it again, but let's do it for, instead of this one, let's do it for this one. Let's plug in the -1 for our x. So we have y equals -1 plus 3 squared minus 1. -1 plus 3 is +2. +2, that whole thing squared. 2 squared means times itself, right? So 2 times 2 is 4 minus 1. Well, this guy equals 3. And so we can go to our graph and graph it, right? So at -1, oh, let me write it down for you. At -1, our answer is 3. So at -1, we can go up 1, 2, 3. That is our answer. So we'll plot that point and check it out. We have a little graph that we can, it's the right side of our parabola. It's that side. Well, guess what? The left side is the same. It's the exact same. And because the way we set it up, we used this even spacing, right? Uh, uh, we used -2, -1, and then just on the opposite side of -3 was 4 and 5. Well, we know because of that, this answer is going to be 0. It's going to be -4, 0, and -5, +3. Stick around and I'll show you why, but look at what that looks like. At -4, 0, we go over 1, 2, 3, 4. It's right there. Oops, I have the wrong thing going. But that's right there. And then on our -5, 3, we can do it again. 1, 2, 3, 4, 5, and then up 1, 2, 3. There's our point. So we'll plot that guy right there. And look at this. We have our graphed parabola perfectly every time. Fast, easy. All you need is 2 numbers and you got it. Now, if you want to stay for the bonus, I got you. Here's the bonus. The bonus is I'll show you how to get those numbers so that you don't just have to guess or believe, Nate here, but you can actually work it yourself and get the answer. Let me erase this real quick here. All right, so what we'll do is we'll plug in instead of -1, we'll plug in this guy right here, 4. So we have, or -4, I mean, we have y equals -4 plus 3 squared minus 1. Well, -4 plus 3 is just -1. We're going to take that guy and square it. -1 times -1 is +1. And 1 minus 1, you guessed it, 0. We've already plotted it. Check it out. Last one. Instead of, let me just change that real quick for you. Instead of plugging in -4, let's plug in this guy, -5, okay? So -5 says -5 plus 3 is -2. You could do it the other way around, 3 minus 5, right? That's -2. Well, -2 times itself. -2 times -2 is +4, and 4 minus 1, because that's just carrying down, is 3. There we go. There's our answer every time. But you don't have to do it. Take the easy way, baby. If you follow my steps, you will succeed and graph parabolas perfectly every single time. Now, it's up to you. Go do it. Practice over and over and over again. That's how you get better at math. Practice, practice, practice. Allen Iverson. We'll see you.